After dismantling so many things, I haven't bought tools in a long time. I heard that Victor recently released the second generation of electric screwdrivers. Let's experience it today. Take a look at what's in here. Here are 27 benches of various sizes. Basically, it covers all kinds of screws commonly found on the market. The two rows above are mainly to screw some relatively large screws. The following row of batches is used to screw some smaller screws. For example, many consumer electronics or some precision instruments use this relatively small screw. This is an adapter used to connect these small batches. Here's also a very mini twist drill. This is a 2mm twist drill. There are two longer batches below, across one word at a time. These two are used to screw self-tapping screws. There's also an extension rod here. This is a USB to Type-C charging cable. There's also a paper instruction manual on the lower layer of this box. Let's take a look at the details of this screwdriver. The size design of the screwdriver is very small, and these two sides are treated with glue. Whether it is electric or used manually as an ordinary screwdriver, it is very comfortable to use. On the back is its nameplate. Let's take a look at these parameters above. The model number is WX242 volts, 5.4 watt-hours, 18,650. This is the battery capacity inside, 320 revolutions per minute, and that's its rated speed. Take a look at its action buttons. The forward and reverse buttons of this screwdriver are separate. In this way, there is no need to switch the forward and reverse frequently. And in order to prevent accidental touch start, here is also a separate design of an anti-accidental touch mechanical switch. Anti-accidental touch switch. After opening, press the forward and reverse buttons. The screwdriver will turn. There are 3 lights. When the switch is turned on, the current battery level can be displayed. The front of the screwdriver is the adjustment ring used to adjust the mechanical torque, a total of 7 gears of torque adjustment. This can be applied to different operating scenarios. Low torque is generally used to screw some smaller screws, for example, the disassembly of digital products, or the repair of products such as mobile phones, etc. The larger torque is generally suitable for screwing some larger screws, or where a certain amount of fastening strength is required. In front of the torque adjustment ring, there's a circle of lead in here. There are a total of 4 shadowless lamp beads inside. When pressing the forward and reverse buttons, L, E, B will light up. It can meet the operation in various dark environments. And the fill light will automatically go out after a delay of 15 seconds. Let's look at the chuck part in front again. The chuck here is the same as most electric screwdrivers. It uses a magnetic design, but there's also a very clever design here. If sometimes the screw is very tight, the batch may get stuck in the screw. After installing the batch, press down gently. In this way, the batch can be firmly locked inside. In this way, there's no way to pull it out directly. It can effectively prevent the batch from falling off. The stability and safety of use are very high. If you want to remove the batch, just push the structure forward gently. In this way, the batch can be taken out very high. It's a very, very clever design. So you're done with what it does. Let's take it apart and take a look at the structure inside. There are only 2 screws in total above. Remove these 2 screws first. Behind this is the Type-C charging port. See, the structure as a whole needs to be pushed out from the front. Remove this tamper-proof switch. This position should be fixed by buccal. It finally opened. The structure of the circle is relatively tight. Torque adjustment ring. It gets stuck on it through these 3 plastic grooves, and by rotating this thing, you can adjust the different torques. This is an acrylic soft board. Set on these 4 LEDs, play the row of uniform light. There's a leaf spring here. This spring piece corresponds to these grooves. In this way, when screwed 2 different torque positions, there's a certain sense of frustration. This way, the entire movement should be able to be pulled out of the case. Before pulling it out, let's remove the forward and reverse switch. Let's take a look at the structure first. The front is the mechanical part gearbox. The 2 wires are connected to the front filling light board. There are also 2 wires in this position connected to the 3-dimensional adjustment spring when you take it apart later. Let's study what these 2 wires do. The middle is what drives it. The motors in the back here is the control circuit board. On the back is 118,650 battery. Keep dismantling back. We separate these parts of the structure. Now, the 2 parts of the structure have been completely separated. So let's look at the structural plates in the back. Take a look at the battery on it. 186502, a lithium battery. This is a power battery because the driving current of the motor is relatively large. Let's take a look at the structure on the circuit board. The surface of the circuit board is painted with a layer of 3-proof paint. It can play a role in preventing moisture. These 4 switches here are what drive the motor. It constitutes 1 H-bridge structure. Control the forward and reverse rotation of the motor. This resistor detects the current flowing through the motor. It can play a certain protective role. This is its main chip control part. It should be a microcontroller. Take a look at the back. There are fewer originals on the back, mainly some resistors and 302s. This is a mechanical switch coming out of the house. 2 buttons that are reversed. The 3 here are indicators of power. This is the structure of the circuit. Let's go back to the mechanics. The motor can be removed. Take a look at the front gearbox. Decelerated by planetary gears. The first stage of deceleration. Here's the second stage of deceleration. Further ahead is a mechanically locked structure. It is similar to a one-way valve. That is, when it rotates through the motor, the chuck in front can be turned. If the motor doesn't turn, the chuck in front is locked. This way, it can be used manually. We take the whole thing apart. Take a look at how the previous torque adjustment is achieved. Now, this part of the structure can be taken apart. There's a circle of bumps on it, and below is a circle of steel balls. The steel ball is pressed on this metal sheet, and the metal sheet is pressed up by this ring of springs by rotating the torque adjustment ring. The more you twist it in, the tighter the spring is pressed. This increases the pressure on the steel ball. The bump on this one will normally be stuck by the steel ball. If the output shaft exceeds the set torque, the barrel will turn against the pressure of the steel ball. So when the torque is exceeded, you will hear a click sound. It is generated by this part of the structure. But why are there two wires soldered in front of this thing? Pay attention to where these two wires are welded. One of the wires is soldered to this sheet metal, and the other wire is soldered to this. So normally the spring press is the metal sheet. The two parts are connected. It's conductive if the set torque is exceeded. As this ring of structure goes over the steel ball, it will push this metal sheet forward to compress the spring. When topping this metal sheet, something like this happens between these two metal structures. So the two touch points are separated. The circuit behind it can detect it. So when this screwdriver exceeds the set torque, the motor will not continue to rotate. This protects the screws. It can also play a certain role in saving electricity. This is the structure inside. Next, we will put it back. It's packed, not a single part. The function is still normal. Well, that's it for today.